What is the mind of God, the object of Albert Einstein's 30-year quest? Einstein aimed to create an equation that combined the gravitational, electromagnetic, and two nuclear forces. He aimed to combine all four forces into a single hypothesis. The God equation is the ultimate theory. One of the greatest mathematicians in history, Leonard Euler, discovered an equation that encapsulated the basic mathematical constants. 0 is equal to 1 plus e to the I pi. The God equation of mathematics is what some refer to it as. Consider a physics-specific God equation instead of the God equation, which is obviously worthless in everyday life. Physics is quite helpful. Newton contributed to the development of the Industrial Revolution by figuring out the mechanics of moving things and gravity. The electromagnetic force was later created by Maxwell and Faraday by combining electricity and magnetism. The development of dynamos, generators, and light bulbs in the electric age. And finally, we had E equals mc squared, which paved the path for the nuclear force. Every time a force was dismantled, human history was altered. And now, in order to realize Einstein's initial wish, we want to combine everything into the God equation. The God equation should combine the fundamental ideas of physics into a single equation, just like the God equation of mathematics. Now, what are these fundamental ideas? Quantum theory and relativity. The issue is that general relativity and quantum theory do not integrate properly. Einstein's general theory of relativity is founded on flat surfaces. The foundation of the quantum theory is breaking things into discrete particles. That goes against Einstein's view that spacetime is represented by smooth curves. That is why it is so challenging. The claim that the greatest minds in the history of the human race have proposed this vast, unifying theory of everything is not hyperbole. Each of them was demonstrated to be abnormal or divergent. Only one theory, string theory, What is string theory, exactly? An electron appears as a dot when viewed from a distance. Another dot is the neutrino. Another dot is the quark. There are so many dot particles here. How many dots are present? Thousands of them. However, according to string theory, if you could look inside an electron, you would find that it is actually a rubber band. A very small vibrating string that resembles a guitar string in size. There are an endless number of vibrations, which is how subatomic particles were created. Each of the subatomic particles can be compared to a unique set of rubber band vibrations. The hypothesis holds true even if you rotate particles into one another, turning electrons into neutrinos and neutrinos into quarks. The string has this symmetry, which is why it is so strong. A straightforward concept that encompasses the entire universe. Currently, in my opinion, string theory is the only hypothesis that makes sense mathematically. Each theory contradicts itself mathematically. Why does that matter? It implies that you can demonstrate that 2 plus 2 equals 5 if you go far enough in your proof. The theory is incorrect as a result. The string theory has proven that 2 plus 2 always equals 4. It may be the only theory in which 2 plus 2 equals 4. By the way, there are numerous arguments against string theory. The main criticism is that you can't test it. But the day of its testing is becoming nearer and nearer. Your mind is blown by this notion of everything. It opens the door to the possibility of time travel, wormholes, the universe before the Big Bang, parallel universes, the multiverse, and other bizarre phenomena. Is it possible to travel back in time to meet your parents before you were even born? Can you use a wormhole to travel faster than the speed of light? We are unsure. That is why string theory is necessary. At the very least, the developed form of string theory has offered strong new techniques for understanding how seemingly conflicting explanations of nature can both be correct, thanks to its mathematical tools that enable researchers to approach issues in new ways. The history of physics can be summed up by the finding of two descriptions of the same phenomenon. James Clerk Maxwell realized that electricity and magnetism were two sides of the same coin more than 150 years ago. Particles and waves can be connected, according to quantum theory. Scientists can now use strings. We will perceive things differently once we are exploring space with elementary strings rather than particles. If using quantum field theories to go from point A to point B is too challenging, consider the issue in the context of string theory. There's a path. Young academics like Beam aren't worried in the least by the fact that it may take millennia to connect all these unconnected threads and create a cohesive picture. His generation never believed that string theory would provide a comprehensive solution. In Robert Oppenheimer's windowed office from when he was Einstein's superior, Degraaff said, "Maybe it's not even feasible to represent the cosmos in one readily defined, self-contained form, like a globe." He was looking out over the expansive lawn at the IAS, the pond, and the distant woods. Nothing about Einstein's talent is diminished by the fact that he attempted to formulate a theory of everything but failed. String theory complicates inflationary models in a variety of ways, not the least of which is the multiverse hypothesis, which holds that our universe is just one of a potentially endless number that were all generated by the same mechanism that gave rise to our own. Between string theory and cosmology, the notion of an endless number of potential universes gained widespread acceptance and was even assumed to be true. In a radically different universe, we wouldn't be here to tell the story, thus the selection effect would be one pretty natural explanation for why our world is the way it is, according to Silverstein. According to Degraaff, maybe the real picture is more like the maps in an atlas, each presenting quite different sorts of information, each patchy. Physics will need to be proficient in many different languages and theoretical frameworks in order to use the atlas. Their contributions will come from a variety of places, some of them far. It's completely confusing and wonderful, in his opinion. Since the advent of quantum mechanics in the 1920s, according to Arkani Hamed, physics is entering the most fascinating period of its history. However, nothing will occur immediately. He remarked, "You should be delighted if you're excited about responsibly tackling the very biggest existential physics concerns ever. But probably not if you need a ticket to Stockholm for certainty within the next 15 years. If there is such a thing as the theory of everything, string theory may or may not be it. However, the theory's extraordinary elegance and promise make it a strong front-runner to continue explaining the universe's workings well into the 21st century. One of its founders and leaders, Edward Witten, stated, "String theory is a portion of 21st century physics that by accident slipped into the 20th century." This is all for today. Give us a thumbs up if you liked the video and subscribe to our channel for other videos. Thank you for watching. Stay tuned with AWZ.